Cathy is one of the Pixel project partners. 3 research engineers, among which 2 PhDs, currently work on it: Charles Garnier, Erwan Simon, and Romain Quiraud. The aim of this video is to introduce you to the energy demand model that has been developed inside the working package 4 of the Pixel project. Let's first explain why it's so important to model the energy consumption of port activities. Energy sobriety, efficiency, and decarbonized energy are 3 key points for the port of the future. In order to reach them, ports need to optimize their energy flows and to have a better understanding of their energy consumption. In small and medium European ports, there is a lack of tools to quantify the energy used for all port activities. Our goal in Pixel is to develop a tool that will help ports to do so. And since cargo is a key piece in a port, our model of energy demand is focused on cargo transition inside the port. Our idea is to provide energy consumption per cargo and much more. Since you now understand our main goal with the energy demand model, let's have a closer look at how it works more specifically. You should keep in mind that all Pixel models have been based and developed thanks to available data issued by the port. It means that the energy model has been built knowing and taking into account the reality of port operations. To briefly sum up port activities, there are only 2 types: cargo in and cargo out, these cargoes being loaded or unloaded from different vessels. Therefore, vessels call are the first data we need for the energy model. The second type of required data is the description of supply chain associated with a specific cargo and the engine specification. Our goal is to obtain a list of ordered port activities. This sounds good, since a specific model called Port Activity Scenario has been developed in parallel in Pixel. So, if we use the output of this Port Activity Scenario model, we will have everything we need to give you all results related to the energy consumption of port activities. Enough speaking, let's see how it actually works. The first thing to do is to connect the energy model to the output of the Port Activity Scenario. As you can see, we now have an ordered list of all port activities that have happened during a specific period of time. We will use this list and do some data analysis and transformation in order to provide a port operator or the port energy manager with the useful information and estimation. One of the main input we can provide is the total yearly, monthly, or daily consumption per type of supply chain. This information will be useful to both terminal operator to have an estimation of how much energy has been used during the process, and port energy manager in order to be sure that the port energy network is properly designed. We can even go deeper in the analysis. Let's have a look. Although knowing total energy used by supply chain is very useful, it is also very important to know the type of energy that is used if we want to optimize it. This information is also helpful to mitigate the supply chain environmental impact. For instance, a port might prefer to use more electricity if it's equipped with solar panels that could produce some. The 2 outcomes we've just shown provide a lot of useful information, but we still miss one main dimension: time. Hopefully, the energy model is able to provide time series for energy consumption. This type of outcome is essential when a port wants to identify its annual peak of consumption, for example. It's also interesting to have access to these results in order to compare energy consumption profile to energy production profile, especially when ports are equipped with PV system. In conclusion, we just want to link what you've just seen with one of the main objectives of Pixel models: decreasing the port's environmental impact. Knowing the energy consumption of the different supply chains and their related emission factors, and by using an approach similar to the one described in this video, we are also able to provide the ports with emissions inventories of their activities. All these results will be fully tested and integrated in real conditions of use in the Port of Bordeaux.